So we'll discuss polygon clipping algorithms. So there are two polygon clipping algorithms, that is Sutherland-Hodgeman algorithm and Weilor-Atherton algorithm. Now, till now we have discussed the point clipping. Then we have discussed line clipping algorithms and various line clipping algorithms like Cohen-Sutherland. Then we have discussed Liang-Barsky. Then we have discussed midpoint subdivision. Now, see the polygon, what is the definition of polygon? Polygon is defined as it is the closed figure formed adjacent lines. So any polygon, this is the polygon. This is the line, this is line, this is line. Then why we can't use line clipping algorithms to clip the polygon? So there is the issue. The issue is, if you apply line clipping algorithm to polygon clipping, suppose A to B, what will be the output? You will get this output as a B, A dash, B. Now for BC, you will get this B, C dash as a output, C dash. Okay, and AC is outside, so you will discard it. Means you are getting, if you apply line clipping algorithm, you will get the output A dash, B, C dash, A dash, B, C dash. Actually, if you clip the polygon by any mean, you will get output as a polygon. But in this case, this is not a polygon. It is an empty or hollow space. It is a blank space between the polygon. So this is not correct output. Hence, to get the correct output, we must need separate polygon algorithms. And what are those algorithms available? So our output must be output must be closed figure. So which are the algorithms for polygon clipping? That is Sutherland-Hodgeman algorithm, and next is Weilor-Atherton algorithm. Now we'll discuss Sutherland-Hodgeman algorithm. Now Sutherland-Hodgeman algorithm, it is used to clip the polygon against the window. So here blue color, it is window. This is a window, and this is the polygon. This is the polygon. Okay, window and polygon. Then this particular polygon, it is clipped against the window. How it can be clipped in Sutherland-Hodgeman? The polygon will be clipped first by using against the left boundary. Then whatever output you are getting, that is provided to the right clip, and it is clipped against the right boundary. Then whatever output you are getting after that, it is provided to bottom boundary clipping, and finally the output you are getting, that is provided to the top clipping against the boundary, and that is nothing but the output of Sutherland-Hodgeman algorithm. Now see here, in Sutherland-Hodgeman algorithm, as I have explained, the polygon is clipped against the left boundary using the rules. There are 4 rules, and that we'll discuss later. Then that left clip output, whatever output you are getting, this is clipped against the right boundary. The same process will be followed for bottom and top boundaries as well. Now see, suppose this is the object and it is clipped against the window. Then first of all, what you have to do, you have to clip against the left boundary. So what is the output? This is the output after left clipping. Then this output will be applied to the right clip, so that it will be clipped against the right boundary. This is the right boundary. So this is the output after right boundary clipping. And then it is applied to bottom clipping. Then it will be clipped against the bottom boundary. And then finally it is given to the top clip, so that upper part will be removed. And finally, once that polygon is gone through those steps, that is left clip, right clip, bottom clip, top clip, the output is nothing but this is the required output. Now for getting the required output, at each stage, at left clip, right clip, bottom or top clip, you have to apply 4 rules. And those are the rules. First rule is, if suppose the edge or line is going from out to in, it is A, B, it is going from out, that is A is outside the window and B is inside the window. So going from out to in, then at that time you have to save intersection point. This is the intersection point, B dash, against the window. So you have to save B dash B. Now second is, if line is going from in to in, that is BC, into in that case save second point. Into out means C, D, D. At that time you have to save intersection point. This is the intersection point. And whenever the line is going from out to out, at that time you have to save nothing. So that Those four rules are applicable at each stage, at left clip, right clip, bottom clip, top clip, and then you have to find the output. We'll solve problem on it so that you can understand how that rules will be applied. Then what are the limitations of Sutherland-Hodgeman algorithm? The limitation is it is best suited for convex type of polygons. We know that polygons are of two types, convex and concave. Convex and concave. Concave. So convex means such type of polygon, if the any 2 points selected from the polygon and the line is completely inside, that is called as convex type of polygon. Concave type of polygon, such type of polygon, if any 2 points are selected, the line is, some part of line is outside, that is called as concave type of polygon. So Sutherland-Hodgeman algorithm, it is best suited or suitable for convex type of polygon. It is not suitable for concave, because if you apply Sutherland-Hodgeman algorithm for concave type of polygon, then you will get a line joining the polygons. So see here, this is the polygon, and if you clip against the boundary or against the window, means what is the output you must get, such type of output you must get. Those two parts must be separated from each other. But in case of Sutherland-Hodgeman, if you apply that algorithm, at that time you are getting the line joining that two means parts after clipping. So this is not correct output. This is not correct output. What is the correct output? This is the correct output. If you apply the polygon boundary or polygon clipping algorithm, then it must separate those two parts, because those are separate after clipping. Now see, if you take the paper and if you clip the paper against the scissor, at that time you will get separate part. So this is the right output, and to get the right output we must modify, means there are some modifications in Sutherland-Hodgeman algorithm, that is called as Weilor-Atherton algorithm. So Weilor-Atherton algorithm is applying all the rules from the Sutherland-Hodgeman except few additions. That additions are, whenever you are moving from out to in, so this is the name out to in, you have to follow the polygon boundary. In that case, you have to follow polygon boundary. And whenever you are moving from in to out, means from this and this in to out, at that time you have to follow polygon, means window boundary, to close the figure, to close the figure clockwise. Now from this it is following polygon boundary, and whenever it is going from in to out, at that time at this location it will follow the clockwise direction and window boundary, so that object will be closed and you will get the separate objects. So this is nothing but the addition done in the Sutherland-Hodgeman algorithm for getting the proper output. Okay, so this is how limitation of Sutherland-Hodgeman will be removed in the Weilor-Atherton algorithm. Now we'll take one example, solve the example. Suppose this is the window, this is the window, and you want to clip the polygon. Suppose this is the polygon, you want to clip against the window. This is ABC as a polygon. You want to clip against the window, this is window, by using Sutherland-Hodgeman algorithm. Sutherland-Hodgeman algorithm. Now I will show you how it can be done. Now first you have to do left clipping, left clip, left clip. Now see here, this is the left boundary. So don't think that this is only the left boundary, it is going from up also. Okay, this is the left boundary. Now apply the rules, 4 rules. As AB, it is going from out to in, so that whenever it is going from out to in, at that time you have to save intersection point and second point. So save B dash B. Now for B to C, it is going from in to out, in to out, you have to save intersection point, that is C dash. So you have to save C dash. Now if you compare AC, that is going from out to out, you have to save nothing, save nothing. So what is the final thing or final output? You have to save B dash B C dash, so that you can draw against the window this clip part against the left clip. You will get the output like this. This is the output after left clip as a B dash B C dash. Okay. Now this output will act as an input for second stage, that is nothing but right clip. So apply this one, not this one. So apply this one, not this one. So right clip, right clip. So what is the right boundary? Which is the right boundary? So this is the right boundary. Okay. Now this is the inside part, this is outside part. Now compare B dash B. B dash B, it is inside the boundary, so that you have to save what? Save B. For B C dash, it is also inside, you have to save C dash. Then C dash to B dash, it is also inside, so save B dash. So what is the output you are getting after right clip? The same output you are getting after right clip also. That is nothing but B dash B C dash. Okay. Now third is bottom clip. Bottom clip. Now what is the bottom boundary? So this is the bottom boundary. Okay, bottom boundary. So for bottom boundary, again apply the rules. Start with B dash B. This is inside part, this is outside. B dash B, this is inside, so that you can save B. Now from B to C dash, it is going from in to out, so that you have to save intersection point, C double dash. So save C double dash. Then C dash to B dash, it is going from out to in, so that you must save intersection point and second point, so that save B double dash B dash. So what is the output? So you can draw the output after bottom clip. So this output is like this. So it is B C double dash P double dash and B dash. Okay. Now what is the next step is clip against the top boundary. So this is the top boundary. This is the top boundary. So you have to clip against the top boundary. Fourth is top clip. Now see, this is the outside part, this is the inside part. Start from B dash B, which is inside. So save B. B to C dash double dash. So that second point you have to save, because it is inside, C double dash. Then C double dash B double dash, both are inside. So save B double dash. Then B double dash to B dash, it is also inside. So save B dash. Means whole output, this is nothing but output also you will get after clipping. So what is the final answer? B C dash, B C double dash, B double dash and B dash. Okay. So that if suppose this is the window, against the window, B is somewhere here, B, then C double dash, it is here, it is C double dash, this is C dash, and B double dash, actually B double dash, and this is B dash. So output is somewhat like this by using Sutherland-Hodgeman algorithm. So this is nothing but polygon after clipping and after using the Sutherland-Hodgeman algorithm. So I think you have understood this algorithm. It is very simple, and at each and every stage, means left clip, right clip, bottom, top, you must apply the four rules. Those four rules must be applied at each and every clipping boundary. Okay, so we'll stop here. Thank you for joining.